extent in the contrast as well as MRI with the gadolinium creates a problem.
Yes. If it is just mild to moderate renal dysfunction, not an issue, but in severe renal impairment, gadolinium causes nephrogenic progressive sclerosis. It causes sclerosis of tissues. So yes, it is an issue. So contrast nephropathy is the issue with whatever investigation you choose.
Not with DSC. Not with DSC.
Sir, not plain DSC, when you are talking of DSC with contrast. If you have to compare with PET or this,
because the lower contrast are coming, then gadolinium, which will not stick to the tissue, and hence it produces much less fibrocytosis.
Yes.
Fibrogenesis.
It causes fibrosis of tissues. It sticks to them. So, now you see all non-ischemic cardiomyopathies. So, it is saying that all that enhances is not CAD, not necessarily. So, what are the various cardiomyopathies? We have dilated, hypertrophic, infiltrative, arrhythmogenic right ventricular cardiomyopathies, and endomyocardial diseases. So, we will see patterns in each of them. What is dilated cardiomyopathy? Ejection fraction less than 45% and LV diastolic dimension more than 58 millimeters. These are the two criteria based on which you call whether this is dilated cardiomyopathy. There can be different types, whether toxin, peripartum, high output or HIV associated. The primary differentiation you have to make is whether this is ischemic or non-ischemic. You can obviously do an angiogram and do, but how can MRI help? This is what we will see. So again, you look at the delayed enhancement only. It helps in differentiating between ischemic and non-ischemic, and it reliably detects the scar with a high degree of sensitivity and specificity. You will have a scar here also, but the pattern of the scar will be different. That is what we will see. So all patients with ischemic cardiomyopathy had a delayed enhancement, which confers to a vascular territory which is subendocardial in distribution. It is associated with wall thinning and wall motion abnormality, that is ischemic. 60% of non-ischemic cardiomyopathy do not have delayed enhancement, so there won't be any delayed enhancement at all. 40% will still have delayed enhancement, of which 28% will have a mid-wall strain. This is important. Delayed enhancement in ischemia is subendocardial because that is the portion most affected. Delayed enhancement in non-ischemic is in the middle portion of the myocardium. So the subendocardium is not enhanced, the epicardial portion is not enhanced. Only the middle white strip will be seen. That is in 28%. So there still remain 12% of patients who will have a pattern similar to ischemic. That means there are 12% chances of false positivity of non-ischemic cardiomyopathy when you try to detect it by cardiac MRI.
Option C, you have territorial.
Yes. Yeah, it won't confer to vascular pattern, and wall thinning will be uniform, not regional.
Stroke and stroke like.
Yes.
Stroke may be right here. It is a stroke of the heart as such.
Stroke of the heart. And it won't have any vascular pattern. Exactly. So, if you see that ischemic, you will have a vascular territory with delayed enhancement, and in non-ischemic, there is lack of delayed enhancement at all. In most of the cases, no delayed enhancement, and whenever you have it, it is in the mid-myocardial. You can see there is mid-myocardial affection. Both sides, it will be non-enhanced, and in the middle portion, you will see enhancement. Do you see it? Classically, in ischemic, it is subendocardial.
40% specificity.
What's the
40% you have.
Sir, in 60% there would be no enhancement, so it is very clear. In 40%, remaining 28% will have a mid-myocardial strain. So that also is easy to differentiate. So in 12% cases it will be difficult to differentiate with ischemic. So now hypertrophic and infiltrative. Hypertrophy, again you know that when you diagnose it, it is called hypertrophic when there is hypertrophy of the myocardium in absence of causes of LVAD obstruction like coarctation, aortic stenosis or hypertension. There is diastolic dysfunction. This is fairly common, 1 in 500. It's not very uncommon.
But lately we have seen most of the echoes cardiac hypertrophy is there.
Yes.
Left ventricular concentric hypertrophy. Correct?
Yes.
Is it common?
Left ventricular hypertrophy is common. with hypertension and
And to the MRI saying something different picture. So this is a deceptive. This is not true cardiac hypertrophy. What we are measuring or recording actually, because there is a contraction of the cavity inside itself. You feel a deceptive hypertrophy of the, so that we overestimate the cardiac hypertrophy.
and you don't visualize the wall pattern, whether there is fibrosis
So MRI scores
over echo. Absolutely. So in hypertrophic cardiomyopathy, 60% of patients have asymmetric septal hypertrophy. 30% of patients have symmetric or concentric hypertrophy. And 10% patients only have apical cardiomyopathy. The rest of the walls are normal. It is more common in the west, far east like Japan. But in India and other places also 10% people have apical, and which is very commonly missed on echo. Because echo is not very sensitive for apical cardiomyopathies. You can actually measure the LVOT obstruction also. You can measure the gradients also by MRI using velocity encoded imaging. You can exactly see the turbulence and measure the velocities. So asymmetric hypertrophy